So in example 2, we are asked to express each number in scientific notation. So in part A, we're given a small decimal number, 0.0005. Well, in order to write this in scientific notation, the first thing that I'm going to do is play some decimal point games. I notice that I have a decimal point right here. I'm going to choose to move this decimal point to the right. So I just moved it to the right one spot. Now, I want to look at where I am right now. And my first question is, am I anywhere near the interesting digits on this problem? The answer is not yet. So I'm going to keep on swooping over until I start getting close to the interesting things. So now I'm close to the interesting things. So now, at this point, I have a decimal in front of that 5. So what I have to have, if I'm going to write down an answer in scientific notation, is a number between 1 and 10. So right now, I have 0.5. 0.5 is not between 1 and 10. So I need to take this decimal point and move it one more place over. And by moving it one more place over, we now have the number 5. 5 point. Well, the number 5 is definitely going to be between 1 and 10. So when I think about this as a number in scientific notation, I start by writing the fact that I have a 5, and then I'm going to write down my multiplication cross there, and then I'm going to have 10 to a power. Well, remember, as I talked about earlier, we're looking here at a small decimal number. Small decimal numbers are associated with negative exponents on the 10. So I'll put a little negative here. And then the question now becomes, what number I'm going to have after that negative? Well, if you count out the number of swoops that we went through, there were 4 little swoops here. So that means then we're going to have a negative 4 power. So there's the equivalent answer as a scientific notation statement. So 0.0005 is the same as 5 times 10 to the negative 4th power. Well, now that we have that, let's check out a number like B. In part B, I have 4,100. First thing to note, I have a decimal sitting there whether I write it or not. So there's my decimal point right now. So now, this time I need to move my decimal so that I end up having a number between 1 and 10 again, but in order to accomplish that I need to move to the left this time. So again, swoop until you get to the interesting things. Now that we've done that, we have 41 sitting there. Once again, my first number, A, has to be between 1 and 10. 41 is not between 1 and 10, so I need to swoop again. Now we're at 4.1. 4.1 is definitely between 1 and 10. So let's come over to the right and write that down. We have 4.1 times 10. And this time we started with a large number. And because it's a large number, that means our power of 10 is going to be positive. Let's count out the swoops and we'll know the positive number. 1, 2, 3. It's going to be a positive 3 power. So there's our answer. 4.1 times 10 to the 3rd power. So using that same idea, let's go back up to that hydrogen atom from the top of the page. We have all those zeros and then the 1, 6, and 7. So if we swoop over, we're going to find that the number between 1 and 10 is going to be 1.67. And counting out, we're going to find that we had to swoop over 24 times to make that happen. And because we started with a small decimal answer, that's going to have to be a negative. So we're going to have 1.67 times 10 to the negative 24th grams. And as I said earlier, trying to write this as that big long decimal is not an easy or enjoyable thing to do. But writing it as 1.67 times 10 to the negative 4th grams, it's a nice, straightforward, and easy way to write it. Well, how about his friend? We have the 1, 5, and all those zeros meters. Well, again, moving that over to get a number between 1 and 10, we have to have 1.5. And if you count out the number of swoops, it ends up being that we have to swoop over 11 times to make that happen. So our answer on that one is that it's equivalent to 1.5 times 10 to the 11th meters.